This video will cover the first page of notes on the topic of rational equations. I divided my page vertically this way, so I kind of folded it in half. And what I did is I put how to solve rational equations on one side step by step, whereas on the other side we'll be doing one example at the same time. So let's solve rational equations. I want to remind you that we can also solve these equations graphically. So if we had, for example, to solve 2x plus 1 over x minus 3 is equal to 9, we can let one side equal to y1 and the other side to equal to y2. We can stick this in a graphing calculator and then find the intersection, and that's another way we can check our work. I will be asking you to use algebra instead of a calculator to solve. So let's go through our steps. For step number 1, our job will be to determine the domain restrictions. This means we need to look at every fraction that we have. In our case, this is the only fraction we have, so we're going to look at the denominator and ask ourselves, when will the denominator equal to 0? When we solve that, we'll find that x is equal to 3, which means we cannot let x equal to 3, because if it does, then our function here, our rational function, would be undefined. So we state our domain to be every number except 3, and this is how we state it in interval notation. To continue solving, the next step would be to kill fractions, especially since we love fractions to death. So what does that mean? That means we should multiply each of the terms by the LCD. So we get every fraction that we have in our equation. In our case, we only have this one fraction. And because it's the only one, then we know what the common denominator is going to be. It's going to be x minus 3. So I'm going to multiply the left side by x minus 3, and I'm going to multiply the right side by x minus 3. We notice that on this side, remember, fractions only multiply other fractions. We can see that this factor will cancel out with this factor, and that will just leave us with 2x plus 1 down here. And then when I multiply over here, I'm going to multiply 9 times my parentheses of x minus 3. Now we can see that we have an equation that we should be able to solve. So step 3 will be to solve for x. The only thing I need to remind you, in our case we have a linear equation, but in the future we may have quadratic equations. And I want to remind you that most likely if you factor it, you can solve it. So let's go on ahead and solve this linear equation. I did the distributive property to get rid of parentheses, and then I need to get all the x's on one side and all the numbers on the other. Because I like positive x's, I am going to subtract 2x on the left side and subtract 2x on the right side, and we'll see that I'll only get a 1 on the left, and on the right side I will get 7x minus 27. Because the x's are already on the right side, I'm going to add 27 to both sides, and I find that I have 28 is equal to 7x. I like to use what I call the duh property. The duh property says if A is equal to B, then I can say B is equal to A. In other words, I can write this as 7x is equal to 28. Solving, I can see that I divide both sides by 7, and I get x is equal to 4. For step number 4, our job is going to be to check our solutions. Now there's two ways of checking. One is to go on ahead and plug in x into our original equation and see if it makes the statement true. But sometimes we also need to take a look at our domain restrictions, because what if we found an answer that was not in our domain? That means our function would be undefined. So that's the reason why it's very important now than ever to check your answers. If not, make sure you check with the domain restrictions. So that means I need to take a look at this x is equal to 4 all the way up here with our domain. And our domain says, as long as it's not equal to 3, you're okay. So we had x is equal to 4. It's in this range of our domain, so we're good to go. And that means the last thing we need to do is to write our answer in a solution set So this is our solution set for x. And that concludes this video.